In today's class, we will take some problem based on Biot-Savart law. First, take down this. A straight wire carrying a current of 12 amperes. A straight wire carrying a current of 12 ampere is bent into a semicircular arc of radius 2 centimeter as shown in the figure. Figure E. A straight wire carrying a current of 12 ampere is bent into a semicircular arc of radius 2 centimeter as shown in the figure A. Question number A. What is the magnetic field? Before that, you write here. Consider the magnetic field be at the center of arc. Consider the magnetic field be at the center of the arc, and here you can write B as a vector. It is a vector. Question number A. What is the magnetic field due to the straight segment? Due to the straight segment. What is the magnetic field due to the straight segment? Question number B. In what way the contribution to B from the semicircle differs from that of a circular loop. And in what way does it resemble? Question number C. Would your answer be different? If the wire were bent into a semicircular arc Would your answer be different if the wire were bent into a semicircular arc of the same radius but in the opposite way? As shown in figure B. as shown in figure B. Now first let me give you the figures A and B, and then we will proceed. First you take down the figures A and B. And then you have a semicircular arc. Here the current direction is clockwise. This is your figure A. Figure A, and then we have figure B given like this. This is your figure B. Now what is the question? A straight wire carrying a current of 12 amps, this current is 12 amp, is bent into a semicircular arc of radius 2 cm as shown in the figure. Now the radius of this semicircular arc is 2 cm. Consider the magnetic field be at the center of the arc. You need to find out the magnetic field at the center of the arc. First question is, what is the magnetic field due to straight segment? First we will take up the first question. Question number A. What is the magnetic field due to straight segment? Question number A. Answer for question number A. Magnetic field due to straight segments. And we know there are two straight segments. Now according to Biot-Savart law, the magnetic field is given by mu naught by 4 pi into ideal sin theta divided by r square. Now here theta is the angle between dl and r, or theta is the angle between the current element and the distance vector. Now if you consider here, to the center r, center C, if the distance vector is r, and if the current element is dl. Now if you see dl and r are parallel to each other, so we can write the current element dl and the vector distance vector r for each element are parallel to each other. Or I can say angle between dl and r is 0, or cross product, you know, sin theta, angle theta is 0 here. Or I can say the cross product dl cross r is 0, because theta is 0, sin theta is 0. From the figure itself it is clear that dl and r are parallel to each other. And in the magnetic field equation we have, if you consider dB is, you know, proportional to sin theta is coming, or sin theta comes in the picture of magnetic field, therefore dB is 0. If you take any current element in the straight segment, the magnetic field due to that current element is 0. Therefore straight segments do not contribute to magnetic field. because the current element and the distance vector are parallel to each other in case of straight segment. The straight segment do not contribute to the magnetic field at the center of circular arc. So straight segment of the wire do not contribute to the magnetic field at the center of the arc. At the center of the arc. The straight segment do not contribute to the magnetic field at the center of the arc. So straight segment of the wire do not contribute to the magnetic field at the center of the arc. Now what is the second question? In what way the contribution of B from the semicircle differs from that of a circular loop, and in what way does it resemble? Now we know B. Field due to the circular loop or semicircular loop. Now a circular loop, we know a circular loop carrying current or in a circular loop carrying current, the magnetic field at the center is given by we can write if a circular loop is carrying a current I amperes, then the magnetic field at the center is we have found this, it is equal to mu naught by 2r, mu naught into I by 2r. Therefore a semicircular loop carrying current will be half of the field due to the circular loop. Therefore magnetic field at the center of a semicircular loop carrying current I ampere will be half of the therefore magnetic field at the center of a semicircular loop carrying current I ampere will be half of the magnetic field provided by the circular loop. Half of the magnetic field provided by the circular loop. So in this case it is mu naught I divided by 2r into half. So half of this divided by half. Therefore it is 4 pi into 10 to the power minus 7 into the current I is given as 12 ampere divided by 2 into 2 is 4, r is 2 centimeter, convert it into meter, 2 into 10 to the power minus 2. Calculate this, it will give you the answer as 6 pi into 10 to the power minus 5 Tesla. And according to the direction, you can apply the screw rule or the right hand grip rule. So you will get the direction is into the plane of the paper direction. Now, would your answer be different if the wire were bent into semicircular of the same radius but in opposite way as shown in figure B? Now, if the wire is bent in this, remember that your magnetic field at the center, the magnitude will remain the same, whereas only the direction will change. The answer for the third one is, if the loop is bent into a semicircular arc as shown in figure B, remember the magnitude of the magnetic field will remain the same, whereas only the direction will change. So here at the center, the direction I will write here only. In the first case, because it is clockwise direction, it will be into the paper. Apply the grip rule, it will be into the paper. Hold your conductor in your right hand with the thumb pointing in the direction of the current. So it will give you into the paper, whereas the magnitude will be same, but only the direction will be coming out of the plane of the paper.